Hey guys, welcome back to another lesson. Today we are going to start our unit talking about three-dimensional solids. Specifically, we are going to start by talking about surface area of prisms and pyramids. So, a couple things that you'll want to have in front of you. First of all, you will want to have your calculator, as always, and then in a separate tab, you might want to have open the 12.1, 12.2 notes, just so that you can kind of look at those and read some definitions on your own screen as you need to zoom in or whatever. So first of all, polyhedra are just solid figures who have sides that are created by polygons. A specific type of polyhedron is a prism, which a lot of you, if you picture like a box, I have this puzzle box right here, right? If I tell you that this top and bottom are the bases, these are the bases of the prism, and they are parallel to each other. And then you've got these lateral faces that go around the outside. So this is a prism, and you can take a minute right now to read that vocabulary, just so you're familiar with it moving forward. So pause the video, take a moment to read about that vocab. Okay. If you haven't already, pause again, read about right prisms. Okay, now let's dive right into our very first example. So when you picture a prism is named by its bases, right? So this puzzle box is a right rectangular prism because its bases are rectangles. What we have in the diagram right there is a right triangular prism because the bases are triangles. To identify the base of a prism, you always want to look for the side, or two sides really, that are not rectangular. All right, if they're all rectangles, then we'll tell you which side is the base, but otherwise you're looking for the side that's not rectangular. So in this, it's a triangle, right? Here it is. We've got our triangular bases. If I sat these right on top of each other, they would be parallel. Note that in the diagram, how it's drawn, it sits like this. A lot of people make the mistake of thinking that this is the base. That is not the base. The base is the shape that's not a rectangle, if that's an option. All right, so to find the surface area, what you want to visualize is kind of unfolding it like this. This is called the net of a prism, all right? So you'll see you have these three different sides. Those are your lateral faces. And then you have these two triangles. Those are your bases, all right? When I ask you to find the lateral surface area, you're finding just the area of the rectangles. So let's start by finding that from our diagram. All right, I'm going to fold this down. So looking here, we have these three different rectangles. So I have a rectangle that I'm outlining in green right now. On the side, that's one of my rectangles, okay? When I highlight it in the diagram, it kind of looks like a parallelogram, but it is not. It is a rectangle. The side dimensions are 13 over here by 20. So 13 by 20, if I multiply those to get the full area of the rectangle, 13 times 20 is 260 square units. So that's my first rectangle, but I've got two more. So I'm going to add in another rectangle that I will outline in pink here. So there we go. That rectangle is created by the dimensions of 15, which is given to me as this side length over here. 15 by 20, which would give me 300 square units. 300 square units. And then I've got one more triangle that I've got to find, which is on the bottom here, that I'm outlining in purple. And that rectangle, it has the dimensions 14 by 20. Okay, so 14 by 20 gives me a surface area of 280. All right, so there we go. So if I add all of those up, that gives me the total lateral area of 840 square units. So if I ask for just the lateral area, there it is right there. Okay, it's 840. That's just going around the sides. Then I need to find the total surface area. So the only part that I'm missing for the total surface area is these bases. I've got two triangular bases. So one over here and one over here. So to find the area, I've got these triangles that I have. The base is 14. The height is given to me as, just draw an arrow there, as 12. So to find the area of one base, I would do 1/2 times 14, which is the base of the triangle, times 12, which is the height of the triangle. 0.5 times 14 times 12 gives me 84 square units. Okay, so if I were to ask you just for the area of the base, it's a triangular base. There it is. Next, to find the total surface area, what I need to do is, I'll split this right over here. So my total surface area would be my lateral surface area, which is 840, plus my area of my base times 2. So 2 times 84, because I have two of those triangular bases. So 840 plus 2 times 84 gives me 1,008 square units. So my lateral surface area in this case is 840. My total surface area is 1,008 square units. Now, for finding the surface area of a prism, there is a shortcut that you can use. So it will always be fine for you to find the lateral surface area by adding up all of those different rectangles, all of their area. But if you look here at that, really, we took 13 times 20, 15 times 20, 14 times 20. All of those sides were created by the perimeter of the base. So a formula that you can use to find the surface area of a prism is you can also say, okay, I am going to take the total surface area is equal to the perimeter of your base times, I'm going to call this 20 that we see in all of these. The 20 is the height of the, is the height of the 3D object. All right, so the height of the 3D object in this case is equal to 20. And then you add to that 2 times the area of the base. Okay, so if we just check that really quick, if we can plug all of these things into our formula, we can do the perimeter of the base in this case. So this equals, area total equals, the perimeter of the base is 13 plus 14 plus 15, which is 42, times the height, which is 20, plus 2 times the area of the base, which was 84. Let's just check it, 42 times 20 plus 2 times 84. That gives me that same 1,008 square units. So for a prism, you can use this little shortcut, this formula, to help you find it, or you can break it down into all of the pieces of what would form the surface area. Okay, so that is that's what we've got on prisms. Next, we are going to talk about pyramids. So take a moment right now to pause the video and take a look at the vocabulary for pyramids. Okay, so you've taken some time to read all about pyramids, and now you guys are pros. I guess I would say that there are two key differences between a prism and a pyramid. Key differences being that a prism will have 2 congruent parallel bases, and a pyramid will only have 1 base. They're still polygons. Okay, great. The other key difference is that, like in your prism, you've got these 2 parallel bases, right? Top it kind of, if you orient it the correct way, they're on top and bottom, they'll be parallel. A pyramid has its base, and then it's got this top point. This is kind of difficult to see. It's got this top point that is a, you can call it a vertex. Sometimes it's also called an apex. But a pyramid, you'll know it if you picture the pyramids in Egypt, right? They come to that top point, that peak. Okay, so those are differences between prisms and pyramids. So you also know that your altitude is if you were to stand at the very top of a pyramid and drop something straight down, that line that's created that's perpendicular with the base is the altitude. And then the slant height is, I've got it drawn on here, the slant height is the height of the triangle that is on one of the lateral faces of the pyramid. So let's dive right into some examples of finding surface area with pyramids. So in order to find the lateral surface area, the first thing that you want to do is find the base and the slant height of your sides. Since I am given that this is a regular pyramid, I know that all of these sides of the base are congruent here, and these are all isosceles triangles going up. So this is a square, right? So if they're all 12 units, right? So I know that I've got these 4 isosceles triangles that are going around the sides here, coming up from the base, and I need to find the slant height. The slant height will be the same for all of these. So if I draw in that slant height, I'm going to call my slant height this cursive L. In order to figure that out, I need to first focus on that triangle, that lateral face. So here I've got this, my base is 12 units. Over here, this side is 10, and my slant height is this guy right here. Okay, so if I take that and just actually focus on just the right triangle, well, then my hypotenuse is 10. This base, I cut the 12 in half, so that's 6, and my slant height is the height going there. So I am going to use Pythagorean theorem to figure that out. Slant height squared plus 6 squared equals 10. You can also recognize that this is a Pythagorean triple. My slant height is 8. So now to find my lateral surface area, actually, since this is a regular pyramid, I have 4 of the same triangle. So if I find the area of one of those triangles, so I'll just call it area of a triangle, is equal to 1/2 times the base of that triangle is 12, times the slant height, or the height of the triangle, is 8. That will give me 48 square units. Now, to find the lateral area, I'm just going to call it lateral area, LA, okay? So that would be 4 times that 48. Since one of those triangles is 4, and I have 4 of them going around the outside, that will give me 192 square units. So that is my total lateral area. The total surface area now is going to be that lateral area plus the area of the base. So to find the area of my base, which is a square, I am going to take 12 times 12, which is 144. And then I am going to take my lateral area and add it to that. So my total area is equal to 144, the area of the base, plus 192, the lateral area, which gives me 336 square units. Okay, so that's pretty easy. I've got a square base, very nice. What if I don't have the square base? That might get a little bit more tricky, as you can see in this drawing right here. All right, so the lateral surface area, in order to find this, because I have a rectangle, all of my triangles going around the side, all of those lateral faces, those are not going to all be the same, okay? I will have 2 of them that have a base of 10, okay, those 2, and then I will have 2 of them that have a base of 18. So if I highlight the sides, there we go. So I need to do a couple of different things here. First of all, I am going to focus on triangle ABC that I have highlighted here. If I look at that triangle, right, I have a base of 10, and I don't know what the lateral area is. And I also don't know what the slant height is. So I need to find that. So I am going to visualize in my head, and this is a little bit difficult to visualize, but if you picture a pyramid and picture someone being at that very top vertex or the apex and dropping something straight down to create this right triangle. So I've got this right triangle that goes through the middle of my pyramid. The slant height is the hypotenuse of that right triangle that I just drew in, okay? So I'm going to focus on this green right triangle that I just drew in. I know that the base of that is going to be 9 because it's half of the 18. I know that the hypotenuse is what I'm looking for. That is my slant height. And I know that the 12 is the other side of my right triangle. That's just the height of the overall pyramid. Okay, so I'm going to once again do Pythagorean theorem and find the slant height, or recognize that it is another Pythagorean triple, but I can do Pythagorean theorem. 9 squared plus 12 squared equals my slant height squared. And so my slant height is 15. So then the total area of this one triangle right here is going to be area equals 1/2 times 10 is the base of that, times 15 is the slant height, which I've drawn in green. So 0.5 times 10 times 15 . So that is 75 square units. Okay, so that's just a half of what I need, or not even half quite. That's just a portion of what I need to do, all right? I'm going to draw in a little separator here that I thought was going to be black. Okay, just drawing a little separator so that now I am going to focus in on these triangles. Let me see here. These triangles with the red base. All right, so this is getting a little bit difficult to see in the diagram, but if you just visualize a pyramid on kind of 2 different sides, that's what we've got going on here. So the actual isosceles triangle that I've got here has a base of 18. And once again, I need to find the slant height. The slant height is what I just drew in blue. Okay, now the height of that right triangle inside is still 12, because that is the height of the pyramid. And I know that this base right here is going to be half of the 10, which is 5. Okay, so once again, I have a Pythagorean triple, or I can do Pythagorean theorem to figure out 5 squared plus 12 squared is, it's another slant height squared. In this case, my slant height is equal to I'll label that there. Slant height is 13. So now to find the area of this triangle, I am going to take 1/2 times the base of the triangle is 18 times the slant height is 13, which gives me what? 0.5 times 18 times 13 is equal to 117. Okay, so now I'm running out of room here. Sorry, but that's okay. I'm just going to do it. I'm going to extend this a little bit. So this is going to that bottom box right here. So my lateral area, LA, is going to be equal to 2 of those triangles that I have in the maroon. So 2 times 75 plus 2 times the 117, which is the triangles that I have outlined in red. So if you think about, if you picture this, these side two, right? Like the net of your rectangular prism looks like this. These two are going to have the same base. These are the ones with the 18 base. And then these two are going to have the base of 10. All right, so we already found the area of those. So now we've just got to do some math with it, multiply them together. So 2 times 75 plus 2 times 117, and not multiply them together. Sorry, I misspelled. Which gives me a total lateral area of 384 square units. Okay, so take a breath here. That one was a little bit trickier, but that's fine. It's just a lot of like tedious work that I need to do on the front end in order to get all of these numbers. It's actually nothing that's like super difficult. I did little Pythagorean theorem, a little bit finding the area of triangles, not too difficult, right? Now to find the total surface area, what I need to do is I just need to take that lateral area plus the area of the base. So my base is a rectangle. So the area of my base is going to be 10 times 18, which is 180. So easy enough, not too difficult. And then I'm just going to find my total area by taking 180 plus 384 to get 564 square units. All right, that is all for today. I hope you guys learned a lot. I hope you guys are doing great. If you have any questions, feel free to email either myself or Mr. Gibbon, and we will talk to you soon. Stay safe.